Hello dear students, how are you? So today I am going to discuss coders. Of course, so last time we discussed address and this going to. So what is encoder? Encoder is basically to encode. If you want to encrypt any information or you can say any set pattern into different pattern, then you must say I'm going to keep the information. This time I discuss the encryption or the encoding from one system from one number. So this is basically combination circuit used to convert a code or data in encrypted mode. It takes 2 to the power n inputs from one end, uses n outputs other end. It means if you have a 2 to the power 3 encoder, it means there are 8 inputs and there will be 3 output lines. And one most important thing, out of 8 lines, out of 8 input lines, there could be only one signal active at a time. So there are uh, many types of encoders, like binary to first is binary encoder, then octal to binary encoder, then decimal to binary encoder, or hexadecimal to binary encoder. So first we'll take the binary encoder. So an encoder takes multiple lines as input at one end and gives less number of output on other end. So we are going to discuss 4 by 2 encoder. Means I am giving 4 lines at one end and it will produce, that encoder will produce 2 lines, output lines on other end. So if I am giving I0, I1, I2, I3, these 4 lines on one end, and I'll definitely get 2 output lines on other end, right? So this is 4 by 2 encoder, or you can say binary encoder. This is also written as 4 by 2 encoder, right? So if there are n input lines, then there will be m output lines where n is greater than m. So if there is a binary encoder, then there will be 4 input lines and 2 output lines as shown in the picture. So if input is 2 to the power m, then the output lines will be m. So if this is the relation to the power m, so here if these are the input lines, then this is the output line. So if 2 to the power 3 are the input lines, then 3 will be the output lines. So here this table shows if input lines are 8, then output lines will be 3. So this is known as octal to binary encoder. If there are 10 input lines, then output lines will be 4, and this would be as decimal binary, because decimal uh, contains 0 to 9 or 10 digits, and that is why this is known as decimal to binary encoder. And if there are 16 input lines, then there will be 4 output lines, and this is hexadecimal binary. And so I am going to discuss binary encoder first. So I have 4 lines, input lines, and on the other end I am getting 2 output lines, that is A0 and A1. So here we'll discuss A0 output and A1 output. There will be a separate combination of two table. So over here I'm going to give you the table of 4 input lines and 2 output lines. See here, this is the encoder, 4 input lines and output lines. And again, I am telling you that out of these 4 lines, one signal could be active at a time. So the truth table should be like this. If I have these 3 lines on input lines y0, y1, y2, y3. So if y0 is active, no output. If y1 is active, the output is a0. If y2 is active, then output is a1. And when y3 is active, the output would be a1 and a0. Okay, this out of multiple input lines, only one line should be active, and depending on the active signals, output can be decided. So output of a0 will be y1. Why y1? Because a0. So high output is this, and high output this. So on these high outputs, the input will be y1, and y1 is active, so output will be a0. And again, when y3 is active, output will be a0. See here, for a0, y1 or y3, these signals are active, so y1 or y3 be active. So output a0 will be formed by the active lines y3 and y1, y3 and y1. So this is yours a0. Okay, output of a1 is high when y2 or y3 is active. Y2 and y3 are active, or y2 or y3, out of any signals, either y2 is active or y3 is active. In that case, your a1 output high. So using these parameters or these signals, you can draw logic circuit diagram. This, so it shows that if a1 is the output, then y2 signal or y3 signal is active, and if the output a0, then y1 or y3 is active. So depending on these signals, we can draw a circuit diagram for binary encoder. So on y3 and y2 is active, it gives a1. y2 and y3 when active, it gives a1. And if y1 and y3 are active, then it produces a0. So this is your binary encoder. And let's move to octal 2 binary encoder. So in octal 2 binary encoder, there will be 8 input lines and 3 output lines. And it is also known as 8 by 3 encoder. So let's see. As you know, octal base or radix is 8. So if you're going to create octal 2 binary encoder, you'll have to consider octal number system. In octal number system, the base is or radix is 8. So you need to have 8 input lines. So for radix 8, R is equal to 8, the following is the encoder given below. So here there are 8 input lines and there should be 3 output lines. 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. The output lines are B1, B2. These are the outputs. So if there are 8 input lines, this encoder will produce 3 output lines. So multiple input lines will produce minimum number of output. So this is the job of encoder, and this time we are going to convert octal to binary. Means this is octal to binary. So what should be the processing and what should be the mechanism of reducing octal to binary encoder? As you know, octal base is 8, so you need 8 input lines for radix this, and for that I am going to create a truth table. So for truth table, I should have 8 inputs, so 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7, and these are the output lines. Okay, B0, B1, B2 are the output. So suppose if you take any octal like 761, and you are going to convert this 761 into binary, so what should you do? If you convert this 7 into binary, 7 in binary is 111, 6 in binary is 110, 1 is binary is 0, 1. So this pattern is the binary pattern, and this is your octal pattern. So you are converting this octal to binary, right? So if you concatenate these three patterns like 111, 110, 001, so 761, octal 761 will have triple one, double 110, 001, because why the combination of 3 bits? Is the reason is because this is 2 to the power 3, that octal, that is 8, and that is why you will have to pair 3 bits for octal. So 7 1 1 1, 6 1 1 0, and 1 0 1. So this is octal. So here input lines are 0 to 7 and output are 0 B1. Now B0 B1 B2 output. So when will it get the high output? So high output means if input is high, only then the output will be available or high. So see here, I'm going to, at a time one input can be high. For example, we make 3 active. Suppose create, if you choose 3, then there should be this combination. You choose 3 means you choose 3, the output will be 1 1 0, and this will be chosen 0 1 1. Likewise, if you choose say 7, means then there'll be this pattern, output pattern 1 1 1, and signals will be high. Okay, so whichever you select, so these signals, the truth table will be high. B1, B0, 1, or means B2, B1 or B0 could be high, get the output 7. So see here, I'm going to take the output for B0, 1 and B2. See here, how to find the values of B2, B1 and B0? The values will be evaluated on high outputs. So if you select B2, then high input is 4, 5, 6 and 7. 4, 5, 4 or 5 or 6 or 7 means OR gate is implemented here. So if you take B1 means 2 or 3 or 6 or 7. And if you consider B0 output, so what should be the high inputs? So B0, for B0, this signal should be high. One should be high, 3 should be high, and 6 should be high, 7 should be high. So this is the way how you can take the output of three signals like B1, B2, and B0. So for that, you're going to create a circuit diagram which I have copied from the book. So this is here. So here 0, 1, 2, 3, 4, 5, 6, 7, because I have copied this diagram from the book, but the signals are the same: 0, 1, 2, 3, 4, 5, 6, 7. So over here, if you see 4, 5, 6, and 7, 4, 5, 6, and 7 on OR gate. Then B1 is this: 1, 3, sorry, 2, 3, 6, and 7. So name doesn't matter. You can anyone, because I have copied from the book, right? So for B0, 1, 3, 6, 7 are the combinations. So 1, 3, 1, 3, sorry, should be 1, 3, not 6, 7. It is 5, 7. 1, 3, 1, 3, 5, 7. 5 and 7. 1, 3, 5, and 7. So this is the output, and this is octal 2 binary encode. Now we are going to discuss decimal to BCD encoder, decimal to binary encoder. And you know what is decimal means? Decimal means 10. So as you know, decimal base or radix is 10. So you need 10 as base, and input lines are 0 to 9. And for radix r is equal to 10, the following is the truth table considered. Like these are the inputs A, B, and input is 0, 1, 2, 3 up to 9, 0, 1, 2, 3, 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this shows this is decimal, and these are the outputs A, B, C, D. Okay. So if signal is 1 is high, then out A is the output. If signal is 2 is high, uh, B is high, then sorry, output is B. If the signal 3 is high, then output is B and A. If the signal is 4 is if the signal 4 is high, the output is C is high. If input 5 is high, then output C or A be high. If output 6 is high, then output C or B will be high. If output 7 is high, then the output C, B, A are high, C or B or A are high. And if input 8 is high, then there will be D will be high. And if the 1 or if 9 is high, then there will be D or A are high. So let's see how to create this decimal to binary. And so this is your decimal to BCD, is binary coded decimal. So there will be 4 bits and 4 bits in, and that is why I have the outputs. And input lines are 10, 0 to 9. These are the input lines, and is producing 4 output lines. So how to find the values of A, B, C, and D? The values will be evaluated on high outputs. Let's see. If you're going to take D, means Input 8 or 9 is high. So 8 plus 9. So plus shows OR. If we use C, means signals 4, 5, 6 or 7 are high, only then we will produce 4, 6, 7. Similarly, if you are going to consider B output, then signals 2, 3, 6 or 7 should be high. 2, 3, 6 or 7 should be high. And for A is the output. Signal 1, 3, 5 and 7 and 9 should be high. So depending on these uh, these inputs and these output, the encoder will be like this. And this is again I have taken from the book. So see here 1 to 9, 0, because 0 is not giving any output, and that is why I have discarded it. But if you want, you can use here also 0 line, but 0 line is not there. 0 line is not passing through any of the gate. So see here for D, 8 and 9 are the signal, 8 and 9. For C, 4, 5, 6, 7, 4, 5, 6, 7. And for B, 2, 3, 6, 7. For B, so here B, 6 and 7. And for A, 1, 3, 5, 7 and 9. These multiple lines are the input, and then it produce A. So this way you can create the encoder, design the encoder, try to understand how to create and what are the combinations and what are the input lines and what should be the output lines. So one thing you should remember, that for encoder there should be multiple lines at one end and minimum number of lines on the other end. So basically this encoder will produce the encrypted information from this device or encoder device. Hope you understand the concept, and if you kindly share it with your friends. We'll meet in the next video, some other concept, maybe a decoder. So till then, bye bye, good day.